Hello, fourth graders. Welcome to Week 7, Lesson 1. This math lesson is for schools who are using the Bridges in Mathematics program. Today, we will be comparing fractions. Are you ready to do some math learning? Let's get started. Today, we will compare fractions using visuals and number lines to understand how fractions relate to each other. Let's break down our objective. Compare means to determine if one number is greater or less than another. We can use these symbols to compare. We will compare fractions using visuals and number lines. One common fractions visual is an area model. Finally, we are determining how fractions relate to each other. This can come in handy for solving real-life fractions problems where you need to know the relative size of each fraction. Think about it. Examine the picture. What patterns do you see? What could the next 3 pictures of the sequence look like? If you have paper and pencil, consider drawing them. Lastly, create your own fraction sequence and share it with someone in your house. Ask him or her what comes next. What patterns did you notice? You may have noticed with the unit fractions in each set of pictures that the denominator increases by 1 every time. It starts with 1/2, then 1/3, and then 1/4. All of these unit fractions are multiplied by 3. You might have also noticed that in each pair of same-colored pictures, both pictures have the same value. For example, the very left picture shows 3/2, and the picture second from the left also shows 3/2. Just in the form of the mixed number 1 and 1/2. You may have predicted that the next sequence of pictures would show 3/4, then the expression 3 times 1/4, and then move into showing 3/5. You may have also found many more patterns than the ones listed. Learn about it. Today, we will be comparing fractions using many strategies. First, let's review the mathematical symbols that we will use to compare fractions. This symbol represents greater than, and this symbol represents less than. Both of these are symbols of inequality, where the two numbers being compared are not equal. Finally, this symbol represents equal to. The equal sign does not mean answer, it means is the same as. Think back. In 3rd grade, you learned how to compare fractions that have the same denominator but different numerators, such as 3/4 and 1/4. Because both fractions have a denominator of 4, both fractions have 4 equal parts in the whole. The denominator tells you the size of the part, so these fractions both have the same sized parts. With 3/4, we are counting 3 of those parts, and with 1/4, we are only counting 1 of those parts. So 3/4 is greater than 1/4. We can put the greater than symbol in the circle to show our comparison. In 3rd grade, you also learned how to compare fractions that have the same numerator but different denominators, such as 2/8 and 2/3. Since they both have a numerator of 2, we are counting 2 parts in each fraction. However, since these fractions have different denominators and the denominator tells us the size of each part, these fractions have different sized parts. Eighths are smaller than thirds. Because you need more eighths to fill the whole than thirds, each part must be smaller. Therefore, you are counting 2 smaller parts with 2/8 and 2 larger parts with 2/3. We can use the less than symbol to show that 2/8 is less than 2/3. In 4th grade, we learn how to compare fractions with different denominators and different numerators. There are 3 strategies that we can use: area models, benchmark fractions, and linear models such as number lines. Let's explore each of these strategies. Let's take a look at the first strategy that we could use to compare fractions, using area models. Area models are a type of visual model. You can draw area models or use digital fraction models. Let's use the Math Learning Center app from the Bridges program to build area models to compare fractions. Here's the website below. It is mathlearningcenter.org/resources/apps. Let's dive in. This website has a lot of free math apps that you can use on any computer or tablet. Today, we are going to use the Fractions app. Since I'm using a computer right now, I'll click to open the web app. Okay, here on the web app, we have a lot of different functions on the bottom. Let's start with the drawing tool. We are going to compare 1/2 and 3/8. Now available here, we have a rectangular area model or a circle model. Rectangular models are easiest to compare because you can place them vertically on top of each other and more easily compare the area by looking at the length shaded of each fraction. Let's build 1/2. 1/2 has 2 parts, since the denominator is 2, and 1 part is shaded, since the numerator is 1. This app can also help by labeling it 1/2. Next, let's build 3/8. 3/8 will have 8 parts, since the denominator is 8. Now, it's very important that the whole for 3/8 is the same size as the whole for 1/2. Otherwise, it won't be an accurate comparison. Yep, those holes look like they're the same size. Now, let's shade in 3 of those eighths. This area model now shows 3/8. Now let's determine which fraction takes up more space in the whole. 1/2 takes up more space of the whole than 3/8. Therefore, 1/2 is greater than 3/8. You can also say 3/8 is less than 1/2. You can go ahead and record our comparison and our symbols. Okay, let's try one more. I'm going to reset the board. And let's compare 2/3 and 8/12. Okay, again, we can use a rectangular model. 2/3 will have 3 parts, since the denominator is 3. Make it a little wider so we can see it. And since the numerator is 2, we will shade in 2 of those parts. 8/12 will have 12 parts, since the denominator is 12. Let's check. Yes, our holes are the same size. And since the numerator is 8, we will shade in 8 of those parts. You can see from the area models that 2/3 takes up exactly the same amount of space as 8/12. So 2/3 is the same as or equivalent to 8/12. These are called equivalent fractions because they are equal. Remember, you can use this website at home to build area models in order to compare fractions, find equivalent fractions, add fractions, and so much more. If you don't have access to the Math Learning Center website or another website, you can also draw area models using paper. Another strategy to compare fractions is to use benchmark fractions. A benchmark fraction is a common fraction that gives you a reference for other fractions. Benchmark fractions are fractions that are easy to picture mentally. One of the most common benchmark fractions is 1/2. Let's use 1/2 in order to compare fractions. Let's go back to our example of 3/8 and 1/2. Instead of using an area model, we can compare the size of 3/8 to the size of 1/2 using reasoning to determine which fraction is greater or lesser. We know that 4/8 is equal to 1/2 because 4 is half of 8. 3/8 is less than 4/8. Therefore, 3/8 is less than 1/2. We can use the less than symbol to record our comparison. Let's try another comparison problem involving 5/6 and 2/10. This time, we will need to compare both fractions to 1/2. Let's start with 5/6. 3/6 is equal to 1/2, since 3 is half of 6. 5/6 is greater than 3/6. Therefore, 5/6 is greater than 1/2. The G next to 5/6 stands for greater than 1/2. Now, let's compare 2/10 to 1/2. 5/10 is equal to 1/2 because 5 is half of 10. 2/10 is less than 5/10. Therefore, 2/10 is less than 1/2. The L next to 2/10 stands for less than 1/2. Since 5/6 is greater than 1/2 and 2/10 is less than 1/2, 5/6 is the greater fraction. 5/6 is greater than 2/10. Another strategy to compare fractions is to use linear models. Linear models show length. A common linear model is a number line. You can use number lines to compare fractions. On a number line, the numbers or fractions farther to the right are greater, and the numbers or fractions farther to the left are lesser. You can either use two number lines with the same sized whole or one number line with both denominators marked on it. It is important to use the same size number lines when comparing fractions. Let's compare 2/3 and 5/8. Using the strategy of comparing to the benchmark fraction 1/2 wouldn't be helpful here because both fractions are greater than 1/2. So let's use two number lines to compare them. On the first number line, we'll plot 2/3. Let's split the number line into 3 equal parts. We can then plot 1/3, 2/3, and then 3/3 is equal to 1. We can indicate the location of 2/3 with a star on the number line. We can use a second number line of the same size and with the same distance between 0 and 1 to plot 5/8. Let's split the number line into 8 equal parts. We can then plot 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then 8/8, which is equal to 1. We can indicate the location of 5/8 with another star. 2/3 is farther to the right on the number line, therefore it is the greater fraction. 2/3 is greater than 5/8. Instead of using two number lines, you can also use just one number line to compare. This linear model shows a variety of denominators all in one number line. You can see that the number line is divided into thirds, fourths, sixths, eighths, and twelfths. You can also easily see equivalent fractions on this number line. For example, 1/4, 2/8, and 3/12 are equivalent because they all occupy the exact same spot on the number line. Let's compare 7/8 and 11/12 using this number line. Here is 7/8 close to 1, and here is 11/12. Although these fractions are very close together on the number line and therefore are similar sizes, 11/12 is farther to the right and 7/8 is farther to the left. Therefore, 7/8 is less than 11/12. You can also use this number line to see how far away from 1 each fraction is. 7/8 is 1 part away from 1 whole. It is 1/8 away. 11/12 is also 1 part away from 1 whole. However, it is 1/12 away. Since 12ths are smaller parts than eighths, 11/12 is a smaller part away from 1, and therefore closer to 1. It is the greater fraction. Now you have learned 3 strategies for comparing fractions with unlike numerators and unlike denominators: area models, benchmark fractions such as 1/2, and number lines. Sometimes it is best to compare to 1/2, and sometimes it's best to use an area model or a number line. You can use whatever strategy that is best for the set of fractions that you are comparing. Now it's your turn to practice. In your Bridges packet, complete page 254, Shading and Comparing Fractions. Then, show what you know by completing page 261 in your Bridges packet, Comparing Fractions with the number line as an assessment. This is what you will turn in to your teacher. Well, 4th graders, it's been a blast hanging out and comparing fractions with you. Until next time, have a great day.